Today's webcast will cover Advanced Corridor Modeling in Civil 3D 2010. We'll be focusing on intersections and the intersection wizard and the best practices for implementing it into your workflow. Then we'll cover knuckles and cul-de-sacs. To get started, I'm going to create an intersection here between Street A and Street B. The naming and the parameters really don't matter because I'm only using this to kind of automate Civil 3D bringing in all of my pre-built assemblies. So I made the alignment in the corridor, but you also see that it brought in all the necessary assemblies for constructing that. So I'm just going to move these a little closer to my work area. Alright. Now, it is possible to take this intersection created corridor and grip edit the start and end regions. And then once that corridor is rebuilt, you'll see that it now includes the longer station range. However, if the intersection needs to be updated, you get a warning that any user-defined regions or edited sections will be undone or lost. So if I continue with that update, you'll see that it goes away. So a better way to construct your intersection, and I'm just going to delete all these alignments, is to start from the beginning with just a simple corridor and then work by adding additional baselines and regions constructing the street, which is what we'll do now. I'll construct a simple corridor, call it Street A. Choose the correct alignments and profiles, and I'll use the primary full road section for my assembly. Setting the existing ground for the daylight target, and there we go. There's my corridor to begin with. Now I'm going to come in here and I'm going to end the first region somewhere before this intersection is going to start. So I'll go into the corridor properties and adjust the end station. And it doesn't really matter, I can just eyeball this and make it exact a little later on. Okay, so now we have this. Now I want to come in here and create an intersection at this same two alignments, Street A and Street B, but add that intersection to this existing corridor right here. So I can name this Street A versus Street B. I'm going to be using the primary ground maintained intersection type. This looks good. Street A finished ground is going to be the priority alignment. And then you can come in here and adjust the offset parameters as necessary for this intersection. Same with the curb return fillets, circular, chamfer, 3-centered arc. I'm going to leave mine at circular fillet and at 25. When we get to corridor regions, instead of having this create new corridor, I'm going to add this to Street A. EG is still my surface to daylight 2. and I'll create the intersection. Okay. So there you see, it creates my intersection for me, and I can just simply pick on this starting region, grip edit it, and snap it to the start. There we go. You'll notice a little bit of offset, 12 foot versus 15. I set up a 15-foot lane for my intersection, but all my subassemblies over here have a default 12-foot lane. And that's relatively easy to fix by simply selecting all my lane subassemblies and adjusting their default lane width to 15. Now when I rebuild the street, I'll see that the lanes match up. Okay. So now I want to continue building this corridor down here to where it meets up with Street C. So I'll go into the corridor properties again, and you'll see that now I have quite a few regions and baselines. So it helps to name these begin of corridor, and then I'm going to add a baseline. Baseline is going to be after first intersection, horizontal alignment Street A. There we go. Now I want to add a region using the primary full road section, following the Street A finished ground profile. With a starting station the same as the end station of the intersection, and an end station somewhere around here. Again, we can rough it in and adjust it after the second intersection is created. Set the target for the daylight to existing ground. There we go. Now we can come in here and create an additional intersection between Street A and Street C. The geometry details are going to remain the same, and again, instead of creating a new corridor, we'll add it to Street A. Now that the corridor is created, I can pick on here, pick the region, and drag it back. Rebuild the corridor, and I'm good to go. Okay. So then you would continue that process along, creating another baseline for this area. I'm going to move on now to the knuckle of Street B. So like before, I'm going to create a corridor, call it Street B, use the appropriate alignment and profile, and again use the primary road full section, setting the daylight target as needed. Alright, so there we go. And like before, I'm going to edit the start and end station. Edit it to the end of the Street A, Street B alignment for the start, and for the end I can just rough it in here again like before. So now I need to address the knuckle area. Starting at this station right here, where the knuckle starts, I need to use a different assembly, one that has an additional lane to extend out to account for this extra pavement. So I'm going to need to split this existing Street B region right here and right there where the knuckle starts and ends. So I'll do that now by simply right-clicking and splitting this region. And just using my object snaps, I can snap there at the start of the knuckle, and there to the end of the knuckle. So again, naming these will help determine where you're at in your corridor. And I'm probably going to change the frequency for curves to 2, tangents to 2, so it's a little easier to see this model. Alright, so now we have this area possessing the ability to use a different assembly. Okay, the assembly that we need doesn't currently exist, but it looks very similar to this primary road full section. So I'm going to copy this down, and this is just MText right here. I'm going to edit it to say knuckle. Okay. For this one, I don't need the curb and the daylight right now. I'll rename this assembly knuckle. Okay. And I'm going to copy this lane to the end of this existing lane here. So now I have the ability to have this lane stretch out to an alignment of my choice. Okay. To help choose this subassembly in the corridor model, again I'm going to rename this to knuckle so it's easier to pick out in the parameter section. Okay. And for that, I can come back in here to the corridor properties, and instead of using the primary road full section, I'll use the knuckle assembly. And again, in the background you'll see that now it's flaring out for that extra lane that I added in. That subassembly, lane outside super, has the ability to tie to a width alignment and a profile, so it can expand or shrink its default lane width and its default lane slope. So I'll come in here to the targets, and you'll see here's my knuckle lane for the width alignment. I'm going to choose a polyline from the drawing, which is just this guy right there. So now it'll expand out to fit that. So I'll come down here and I'll do the same thing. Corridor regions, and I'll split this last region based on the start of the knuckle. And the end of the knuckle. I'll change its assembly to knuckle, edit its frequency, and change its target to this cyan line. So now I have the basics of my knuckle created. Of course, I need to add on a curb and a daylight assembly all the way around this. Now, if I, just to show you what it'll look like, if I copy this to that right there, and I also, you'll see here, I'm continuing the slope down. I'm going to want to come in here and adjust that default lane slope instead of -2 to a +2 so that I can drain it back to the street. Do the same thing for this curb assembly. There we go. Now when I rebuild Street B, you'll see that the curb assemblies run perpendicular to the centerline alignment, which isn't necessarily what I want. I need these curb assemblies to come out perpendicular like that all the way around, so I get a more accurate corridor model. So the utility that we use to do that is an offset assembly. An offset assembly allows a piece of a assembly to follow a different alignment and a different profile than what the main region is working off of. Okay, so I'll delete this. I'm going to add an offset, and graphically it doesn't matter where I pick, because that will follow whatever alignment or profile that I choose later on. But I'm going to come in here and copy that same curb and daylight. And adjust their slopes real quick. Alright. So now I need an alignment and a profile for this to follow. It can't just follow a polyline. So what I'm going to do is I'm going to extract out, as soon as I rebuild this, okay, here you'll see my assembly offset. It doesn't know what to follow. I'm going to extract out this edge of travelway here along the knuckle. Extract out the alignment and the profile, and then tie that alignment and profile to this target. Okay, so alignment from corridor, choose on my edge of travelway, pick on that feature line, edge of travelway, pick OK, and I can just call this knuckle ETW for knuckle edge travelway. It's an offset. I don't need any labels on it, and I'm going to have it create a profile for me. Alright, now if you just want to see that, I can create a profile view for the knuckle edge travelway. There we go. So there's my knuckle edge travelway right there for the first one. And then I'll do the same thing for the second one in a little bit. But for the time being, come in here to the corridor properties. Okay, and now you'll see knuckle 1, offset 1. It's looking for an alignment. I'll tie it to the knuckle ETW and tie it to the Street B edge of travelway profile, which was automatically created. Apply and OK. And now I have my corridor model looking like I want it to. Now the curb runs perpendicular to the edge of travelway instead of to the center line alignment. And I would repeat that same process down here. Extract out the edge of travelway alignment, the profile, and then tie this to that. When I come down here now, skip down here to the cul-de-sac. So same steps, corridor, create corridor, choose my correct alignment and profile, primary road full section, street C, and since I did a normal corridor, I can edit the start and the end station from the get-go. So I'm going to start it after the street A, street C intersection and end it where the cul-de-sac begins. Alright, so there's my street C. Now I need to create an alignment for the assembly to follow around this, and then I'm going to target the center line alignment and the center line profile for street C. Alright, now to do that, I want to create a corridor surface to sample off of. So let me show you what I'm going to do. I'm going to create an alignment from this polyline. I'm going to accept the direction. You'll see that it's going counterclockwise. That's fine. Call this cul-de-sac. Don't need to add curves, and I don't want to erase the existing. And I don't need any labels. Alright. So now I need to determine what the starting elevation is for that point right there. So to help me out a little bit, I'm going to increase my end station a little bit, bump up my frequency so I get a little tighter corridor model. And then I'm going to make a surface from the top. It doesn't really matter how I display it. Okay. So now when I sample the existing ground for this alignment, I can also sample this street C surface so I can get my starting and my ending points that I can snap to. You can do it through the inquiry, but it doesn't really matter how you get that elevation. Okay, so I'm going to create a surface profile. And you'll see there now I can sample through street C top. Make sure street C looks like a layout. Adjust the datum as necessary. There we go. So now here's my start and my end elevation for that cul-de-sac. So I can come in here, create a profile, and you can do this however you want to design it. Just come in here and give it a low point somewhere here in the middle. point. And that's all I need. Okay. So now that I have an alignment and a profile, I can add an additional baseline here to my Street C corridor. Call it cul-de-sac. Use the cul-de-sac alignment. Cul-de-sac FG finished ground. I'll add a region. I'll use the curb return fillet. It happens to be just what I need. So if I apply, I'll see that it comes all the way around. What I need to do is stretch this lane to meet the center line alignment and the center line profile. Okay, so the first step, I want to bump up the frequency so I get a tighter corridor model. Bump that up to 1 on curves. And for my target, line outside super left, I'll choose my Street C alignment. And for the lane outside super, for the outside elevation profile, I'll choose the Street C finished ground profile. And now I can also, while I'm here, edit the end station for my starting street. Which is back there. Applying OK. And there's my surface, my corridor. I probably have to come in here and add in my, there we go, target surface, EG. And my corridor is modeled. So we covered how to do best practices for intersections and creating it so that when the intersection parameters change, it doesn't reset your entire corridor. How to create a knuckle. Now this is non-dynamic, so if I wanted to change the elevation of this knuckle target, I'd have to adjust this profile down here that I made. See, I can pick on it, I can adjust it, I could relay in a new one, or I could go through that extraction process to re-extract it. And then we covered how to add in a cul-de-sac to your alignment. Now there is one caveat. The Street A, Street B, if I pick on that, you'll see that Street B is locked to what Street A is doing. You can only have one intersection per alignment combination. So Street A and Street B would be a combination. It can only have one dynamically controlled intersection. I can come up here and create an intersection and it will create it correct the first time, but if Street A or Street B adjusts, it's not going to have these dynamically linked PVIs. So that's something to be aware of. A workaround might be to split Street B into two alignments, so Street B begin, Street B end, and that would give you the option to have an intersection for both ends. Okay. So that concludes today's webcast. Look forward to part 2 where we'll be covering medians.